to begin. So, Skysweeper, low-budget orbital debris removal. This is a really out-of-this-world topic. So, brief overview for everyone. Now, orbital debris can create a cascade of space trash. This is known as the Kessler scenario or Kessler Syndrome. It was depicted in the 2013 movie Gravity, and the problem with debris increase exponentially. One errant satellite can whack into another, creating a giant shotgun blast of space trash that wipes out anything around it. And most of the solutions proposed are really, really expensive and convoluted. So they include mechanical capture, various types of mechanical arms, various types of propulsive beams, drag methods like trying to slow stuff down, trying to catch things that are moving at several kilometers, like 10 kilometers a second and up. So a lot of this requires costly infrastructure, like putting a giant laser on Earth or putting a giant laser in orbit, which can compound the situation if orbital access is already compromised. This is just a little paper that did a lit review of different techniques here. And as you can see, a lot of them use very complex terms and very complex technologies, some of which have not yet been fully developed and matured. So to move on, is there something a little bit more affordable? In low Earth orbit, that's kind of where the biggest part of the scenario is, because in order to get through that, you need to get through space, you need to get through low Earth orbit. That's a couple of kilometers up, about 2,000 kilometers. And things are going to be moving at 8 and 9 kilometers a second. So how do we clean up stuff at large volumes? Fortunately, history has some interesting examples. Now, early artillery weapons used low accuracy for volley fire. Examples would be organ cannons or organ guns used in the Renaissance in Europe, or the Korean wacha used in the Imjin War in the 1590s against the invading Japanese. Essentially using a lot of projectiles to cover an area, even if each individual projectile has low accuracy. Some contemporary examples of a similar thing include point defenses, like a battleship defending against cruise missiles using a mounted machine gun, and the Metal Storm system developed by an Australian inventor in the 90s that uses electronically ignited rounds to shoot down incoming missiles on tanks and aircraft. Now, my method is essentially a simultaneous discharge of low power rockets dragging nets and tethers. It can be mounted as a point defense on spacecraft, say like the ISS. Also, it could be used as a handheld line launcher, like for search and rescue, like whether it's overboard sailor or something at sea, even, or in space. If there's a piece of debris or an EVA failure and you need to rescue someone. Essentially, a low power model rocket engine combined with a net and or bag behind it. So I tested out with low power model rocket engines, and with optimization, I've measured and deployed a few characteristics. These are some of my latest prototypes made with my 3D printer here. Essentially, the way it would work is that you string the net or a bag through the loop on the front, and it would ignite from the rear. These would be discharged in a large volume, and they would basically burn up in the atmosphere because they have an unpredictable orbit and destroy more trash than they create in the process. This could be used over a wider area to help clear out a large concentration of our orbital debris. So I tested this out essentially using a rig with a line between two posts and measure the acceleration and speed. Essentially, I'm using model rockets between the category A through E. Model rockets are rated by thrust and power. I'm using hobbyist grade stuff. Generally, that's category F and below. So now, essentially, we designed a low mass gyro jet with drag lines. We presented these and we use low cost parts. So we're trying to make a low cost, reliable cleanup system based loosely on some historical artillery concepts for developing countries and space startups. I'll be happy to address any questions you might have. I hope I really can rock it. Thank you.